Thank you, Frank.
All right.
Appreciate it. Yes, my name's Lydia. Thank you for coming to my talk. Very excited to be here. It's my second ever technical talk. My first talk this year was in WESIS. I really enjoyed it. I applied for SANS. I got accepted. I said, oh, and now here I am. So be gentle with me. I'm still figuring out the technical part of speaking, but not the word part of speaking because I have a little practice with that. So what are we going to talk about today? This is my talk title, very proud of it. Any chance I can use to do funny titles, I take. So here's a little synopsis of what we're going to do today. Tell you a little bit about me, why we're doing this presentation, how threat detection used to be versus how it is in the cloud. We're going to talk about the perpetual discovery process and the shared responsibility models of the big three. We're going to do a little case study and dive into business email compromise and how the logs vary across different vectors in M365. Give you a couple takeaways and things that you can bring back to your company and say, we need to do these, and then we'll have some time for questions. All right, so me, I am, as Frank said, a threat detection engineer at Edward Jones. I'm on the TED team, Threat Emulation and Detection. I love my team. I also love to say that I'm now doing a TED Talk. I've been in tech for about 8 years, a detection engineer for almost 5 years. I was a former English teacher. I got my master's in international relations, got really interested in cybersecurity policy, thought that Mandiant's ABT1 report was the coolest thing I'd ever seen, wanted to do that, had no idea what that was. Decided I really needed some technical skills, so I started on a help desk as a tier 1, worked my way up to be an on-site sysadmin. Long story short, moved to an MSSP, moved to App Omni, now I'm at Edward Jones. So I like gardening, I do stand-up comedy, and I needed a third thing, so I put hype trains. Why am I doing this presentation? Because cloud threat detection is hard. It's frustrating. There is a lot of hidden pitfalls that would have saved me a lot of time had I known starting out. I want to save you these many hours of frustration. And it's also an opportunity to make jokes, which I love, and some puns. So I want you today to understand why we need to shift our mindset around threat detection for the cloud. I want to inform you how shared responsibility models shape our detection requirements. And I want to give you some resources for the cloud detection engineers. So traditionally, threat detection could be boiled down to these 4 phases. And there's a variety of ways that we could, slice and dice these. But at their core, it kind of broke down to this, right? We had the discovery phase where it's like, OK, I'm a detection engineer. I need to do a detection. How do I get information about what detection I'm going to give? Maybe corporate comes to you and says, we're really concerned about this attack. Find information on what this attack is. Does it apply to us? What logs do we have? Build a detection on this. You might get information for the threat hunt. You might get it from your CTI, Cyber Threat Intelligence Department. Variety of ways you could get information for the discovery. Then you move on to the development phase, which is actually writing the code for the detection. Then you test it, you deploy it. Maybe you go back to the development phase. And then eventually, finally, you decommission the detection, right? It's no longer useful. You've patched the vulnerability. You've removed the VM, whatever. You don't need it anymore. And these used to be pretty static, right? It used to be kind of like carving Mount Rushmore, where you would build this beautiful work of art, and you would be confident that it would stay the same for at least 2 years. And that is gone, unfortunately. We have moved from Mount Rushmore to the Buddhist San mandalas, where you just put it together and at the end, you're just going to flip the whole thing. It returns to the sand which it came, and it's not nearly as permanent as it used to be. Because in the cloud, we have what I like to call a perpetual discovery process. Every cloud has a different security philosophy. AWS handles security real different from GCP, handles security real different from Azure and M365. The attack techniques are poorly documented. The platforms change really quickly. The logs are not standardized. They're really unintuitive. And the worst part is that it's going to take years and years for everybody to sort of agree on what the best way forward is. For an example, who is familiar with syslog? Raise your hand. Yes, good. Everybody knows syslog. Do you know how long it took to get an RFC for syslog? As a protocol? 30 years. They started developing SendMail, and I think it was 1972. They didn't get an RFC on the protocol and standardize it until 2009. This stuff does not move quick. unfortunately. So like this is hard for detection engineers, right? Because we like repeatability. We like to be able to predict what's coming. Like that's kind of our bread and butter. And I can talk about this with words, right? But what I really want to do is give you an example of the logs and how this manifests in business email compromise. So business email compromise for the super new is basically when your email gets hacked, and attackers can do a variety of things with a hacked email account. Maybe they sniff through it for contacts that they can then attack further. Maybe they look for important financial information. Maybe they use this to like look for passwords or other unsecured information that they can then privilege escalate and so forth. So, oh, these ones don't have the demo slides. Okay, well, I'm going to talk through this with you because I had an updated deck that had a demo on it, but I don't think those made it into this deck. So we are going to roll with it. So let's pretend that I am a detection engineer, right? And my tenant is using M365. And my boss comes to me and he says, Lydia, we're really concerned about business email compromise. I want you to do detections on business email compromise and how I do it. I'm like, okay, boss, I got this. I got this. And so I'm looking around, right? I'm looking in the admin portal. There's 15 different admin portals in M365. 15, fam, 15. They're all different. They all have different settings. It's nuts. And so I was like, okay, well, Exchange, right? Exchange is email. I'm going to go to Exchange. I'm going to go to Exchange. I'm going to look at the mail flow rules. And if I create a new mail flow rule, that sends email outside the organization, right? And that's bad. And that's email compromise. So if I write a detection on this, I can detect a business email compromise. Okay, I'm done. No, you are not. Because your boss comes back to you and like, wait, what about the individual mailboxes? Like, individual mailboxes? Yeah, those generate separate logs. Because when you generate mail flow rules, you get what's called a new transport rule in the logs. New transport rule, but I thought I created a mail flow rule. Why is it a transport rule? Because it's a transport rule. So, all right, so Exchange admin creates transport rules in the mail flow rule. Okay, well, now I got to go look at the individual mailboxes. So I go to my OWA portal, my Outlook web app, right? The web app version of Outlook. And I am create a new mail rule there to like exfiltrate information. Like, okay, well, this one is new inbox rule. No, this one is update inbox rules, right? That's what that shows up as the log source. Is that different from new transport rule? Yeah. If I create a new inbox rule, is it going to detect on transport rules? No. Do I have to now create 2 different detections for the same technique? Yes. Or combine that logic together so that it detects on the same thing on both places. All right, so I got my OWA, I got my Exchange admin portal. I'm done, right? I'm good? No, because this is just OWA. There's still Outlook desktop client, and that creates something different than either the OWA or the new transport rules. That one is update inbox rules. No, that one is new inbox rule. And I will add notes to this at the end of the presentation so that you can keep all these straight. So yeah, now we have 3 different logs, 3 different places you can create email rules. Okay, I've got 3 different sources of my detection. I should be done, right? We should be good. Who thinks we're done? No, we're not done. Because you can go create a spam outbound policy that also exfiltrates information, because that makes sense. You can BCC yourself on an email whenever you get an alert, and all of a sudden, you're looking in the Microsoft Defender portal on exfiltrating email rules. And it's like, who would ever think to look for? And the log that it creates is something like set outbound host spam policy. Now, if you were looking at the log source and saw set outbound host policy, who would think to themselves, yeah, that sounds like email exfiltration? Nobody would. Nobody would, fam. That doesn't make any sense. You have to know the product in order to understand that this is something that you can do with exfiltrating email, right? You'd have to go in and actually look at it, make the setting change, see the logs, be like, somehow set outbound host spam policy exfiltrates email. Okay, noted. All right, who thinks we're done now? No, No, we're not done, because there are exchange connectors. There are Power Automate, there's PowerShell, and all of those techniques require totally different detection mechanisms. And so when your boss comes to you and says, detect on business email compromise, you got to do a lot of work. And you got to look in a lot of places. And you got to do a lot of stuff that just intuitively is not something that we would think about doing from a traditional detection engineer standpoint. So what do we do? You need to understand what your responsibilities for the platform are. 2 out of the big 3 require really deep, in-depth knowledge of their IAM infrastructure at every AS level, IaaS, PaaS, SaaS level. Sorry, Edward Jones. I need you to enumerate your clouds thoroughly and regularly. You need to have good logs, because it's very easy to miss data sources in the cloud, especially with Microsoft. You also need to know what logs your environment generates for a detection, right? Who knows about the big controversy about E3 versus E5 logging in Microsoft 365? Who's heard of this? So long story short, E3 licenses are licenses that you can assign to users in M365. They do not have the additional security features that E5 licenses have. And this is a big component in a lot of breaches. You could do what's called a licensing downgrade attack, because when you assign E5 licenses, you get more visibility into what that account's doing, right? But you can also downgrade that license from E5 to E3. The users can still use all the products that they were using with E5, but now you don't really know what the accounts are doing, right? You lose that additional security logging, you use that additional vulnerability, and it's something that's not obvious, again. And it's not just with the end users either. It's with the Azure tenants themselves. There's P1 versus P2 licensing. There are actually entire classes that you can take on Microsoft licensing. It is that complicated. I used to have the website. I can supply the website afterwards if you are morbidly curious. But yeah, it's complicated. It's not obvious. Different levels of logging licensing will generate different logs. So you got to know what you're going to get whenever you trigger detection in your environment. Because if you have a detection that's written for E5 logs and everybody in your tenant is using E3, is that detection going to fire? Nope. Nope, because it's relying on details that you're not getting, right? So finally, what you need to do is have continuous automated detection validation. These platforms change all the time, right? Pretty much every presentation I've sat and said, this changes all the time. It is constantly evolving. We don't understand how it's changing. But the sad part for detection engineers is every time the platform changes, the log changes. Every time the logs change, our detections break. So you got to let this Mount Rushmore thing go. Let it go, fam. It's not Mount Rushmore anymore. Your detections are going to break. It's okay. We got to accept that they're going to break. We got to know when they break, because what's worse than having no detection? A broken detection. Because when you have a broken detection, you think you're covered, right? You think, I'm good, I got this, I can detect in all the 17 different admin portals, right? And that's really going to throw off your responders, right? Because they think, oh no, we're good for this. Like, what's all this weird activity going on? Like, why do we have this? Like, suddenly we're getting all these outbound spam emails. Like, I thought we had detections for like business email compromise. What's the deal? And it's going to throw a lot of people off. It's not just a you failing at that point. It's like an everybody problem. So like, let's avoid that. Let's accept that our detections are going to break and just build that into our process. So I want to explain the shared responsibility models for each product. This is AWS, right? We've talked, you've heard at this point about AWS, about how I think the Roblox guys are next, and I was creeping on their presentation. They said there's 16,000 different permissions for AWS now. Oh, but they require you to understand, they require you to secure stuff if you use their platform, right? That's not optional. The shared responsibility means that if you use this product, you have to secure these things, right? It's not that you give us all your data and we take care of it and everything's fine. It's that, no, we have mutual obligations to each other. It's, you need to secure not only your data, you need to secure your platform applications, identity, and access management. This is where people really trip up the IAM. The operating system, network, and firewall configurations. Again, people goof up here, right? But it's the software itself that you don't need to secure and the hardware itself that you don't need to secure. So look into these. Get familiar with these controls. Get familiar with these platforms. This is AWS. This is M365. And you'll notice here that they say you always have responsibility for your information and data. You always have responsibility for your devices, whether they're mobile or PCs. You always have a responsibility for your accounts and identities. It doesn't matter if it's SaaS, PaaS, IaaS, or on-prem. Always have responsibility for accounts and identities. And this requires understanding identity and directory infrastructure, right? Because how are you going to understand your identities if you don't know how the stuff works? You need to understand how it works. You need to be familiar with the platforms. You need to get in there and be able to tweak stuff and see what the log output is, because right now we don't have that visibility. But you'll see too that these responsibilities change depending on what level of the platform that you're using, right? Some of these are shared, and some of them are not. So let's move on to, and this is Google. Google is nice. GCP is probably, I think, the nicest cloud platform to use because they're like, yeah, fam, we've got you. Don't worry. Like, you only have to be responsible for some things, right? If you're using our SaaS policy, like, you're responsible for the content and access policy, but we got you. For everything else, we got you. For PaaS, still have to be responsible for identity and operations, but that's a lot nicer, I think, than some of the other platforms. But you'll see too that like this one-size-fits-all approach to securing stuff in cloud doesn't work either. Because if I went into AWS, if I go into Google with like the same mindset that I do as AWS, like I'm going to do a lot of work I don't need to do, right? Because if I'm using SaaS for Google, but I'm approaching this like I'm securing AWS, I'm going to go down a lot of rabbit holes I don't need to. So let's avoid that too. Okay. So other things we can practically do, you need to have good logs. You need to have good visibility, right? In this slide deck, there is a guidance on implementing M.21.31. This is an excellent document that outlines all the different log sources that you need to be ingesting. If you're using these cloud environments, read this, get familiar with this, but also know that Microsoft loves to change things. Microsoft Advanced Audit in this document is now Microsoft Purview Audit Premium. Again, very on par for the course for Microsoft. Like this stuff changes all the time. You also need to have visibility into your log ingestion, because if you can't get events into your SIM, your detections are never going to fire, right? Because detections are just like, what's the word I'm thinking of? Can't think of the word. Doesn't matter. But you need to have visibility into your log ingestion, because if you're not getting events, your detections aren't going to fire, and responders can't do their job. It's going to be a problem for everybody. Throttling is also an issue. So throttling is where the events don't flow at the rate that you would expect them to. Maybe the vendor says that, oh, well, we're only going to allow you to have like 2,000 events per minute, and you're actually generating 10,000. Is that good? No, it's not good, because then like you have this giant back pressure. Maybe you won't get the events for a certain incident for several hours, right? You can also have integrations that break. You can have just a lack of events at all. Maybe your log sources aren't configured correctly. So look at this as a document. Make sure you have all these log sources. Know that the log source for Microsoft Audit is now Purview Audit Premium. Be aware of your log ingestion. Okay. Other things, log sources. These are some of the log sources that this is a document outlines. CloudTrail for AWS. Azure AD is now Entra ID. The activity, audit, and sign-in logs, amazing, love it. Google has admin activity audit and data access audit, love that as well. M365, they say use the unified audit log, but here's a secret, is that if you're using M365, you're also actually using Entra ID. Even if you're not doing any VM stuff, you're not doing any PaaS, you need to have Azure AD/Entra ID logs if you're using M365, because they are so much better. They have so much more details. They have so much more context. If you are only using M365 in your environment, use the Azure ID audit and sign-in logs. I mean, you're still going to use the unified audit logs for some specific things around like the access to the software itself. But as far as like who's signing into the platform, different identity controls, audit and sign-in logs for Azure 100% all day. Use those. The other thing too is that you need to turn on individual mailbox auditing. If we think back to my BEC example from 10 minutes ago, I talked about two different mailbox detections, right? One for OWA, the Outlook web app, and one for the Outlook client. If you don't have mailbox auditing enabled, you're not going to get those logs. And now, if you have a new tenant, this setting is enabled by default, but it didn't used to be that way. So everybody, when they go home, if they're using M365, is going to make sure that they have mailbox auditing turned on, okay? Put your finger on your nose if you understand you need to turn on mailbox auditing. Very good. Okay, awesome. So we got to turn on mailbox auditing. We got to use Entra ID logs for M365, even if we don't use any Azure stuff itself, all right? All right, the other thing we got to do is continuous validation. Continuous validation means that we're always detecting, making sure that our detections are doing what we expect them to, right? Because if a detection breaks or the log source breaks, we need to know about it now rather than later so that we can fix it. And there's some tools that you can use to do this. Atomic Red Team is great. It's open source. It's free. So you can use the Atomic Red Team PowerShell to sort of like simulate these attacks, make sure that these work in your environment, the logs haven't changed. You can test this way. GraphRunner, another great tool from Black Hills Information Security. Amazing for validation. At Edward Jones, we're standing up Prelude Security. We're going to use them for continuous validation. We've been very happy with it so far. And yeah, I think I sped through this a little faster than I thought I would, but I also had to talk through my examples. So hit me. Questions, what do you got?